Welcome to the Automation Technologies module. And really in this module, I want to dive into workflows, why we have them, how we can use them, and then just some technologies that work with PowerShell for maybe scheduling, for hosting these longer running jobs potentially, but also just those short, hey, I need to perform this task, i.e. Azure Automation and Azure Functions. Now in the past, you would have heard me talk about things like Orchestrator, SMA, but that's really not utilized much anymore. We think more about having these cloud engines that can still operate in a hybrid world, i.e. on premises, through extensions of various types of worker. So why do we need these workflow things? And there's a challenge when I have something that runs for a really long time. Now, if a script finishes in a second, it's probably going to be fine. The chances of something crashing during that 1 second execution are fairly slim. But now let's take a script that takes 5 minutes, 10 minutes, an hour. When we start to get into those durations, not only is there a chance of it crashing, but there's a chance that I have to perform some kind of scheduled maintenance. I need to pause the job and then resume the job. Now, if there was some interruption, I just had a regular PowerShell script and I did nothing special, what would happen if I tried to just start a script? Can I just rerun the whole script? Remember we talked before about most actions are not idempotent. I can't just rerun it as many times as I want. So I would have to have scripts that have checks all the way through it that says, well, has this bit been done? And if it has been done, is this in the right state? That is very painful to do, and it is very time consuming. So as you might have guessed, workflows are designed to solve this problem. It enables me to take a very complex sequence of actions across maybe multiple machines that may take a long time. It doesn't have to be a long time, but when we think about things that do take a long time, workflows are fantastic. Because with a workflow, I can pause it. I can resume it. I have the ability to take checkpoints within the workflow, and at any of those checkpoints, I can check the state. I can resume from them. So everything stateful about that execution would be stored as part of that checkpoint. I have additional types of parameters so I can control the workflow. A list of machines, credentials to which I'm going to run the workflow as, quotas related to runtime environment utilization, a retry count. And they don't have to be complicated. This is a workflow. Like most things here, you can see, well, look, I'm creating a workflow called my workflow, and it consists of write output hello from workflow. And then after I've defined it, then I can execute, i.e. just run my workflow. So if I was to jump over here, and here I'm in my VS Code, and there's that workflow, and you'll notice there's red underlines on everything related to workflow. Workflows are currently not supported in PowerShell Core. So I have to use Windows PowerShell for this. So I'm actually going to open up a Windows PowerShell instance. I'm actually going to try this. We're going to see if this works. So what I can do, instead of pressing F8, I'm going to do Control-Shift F8. So what that should do is execute in my currently selected terminal as opposed to the default terminal. So if I do Control-Shift F8, yep, that executed in my currently selected terminal. So that's defined it. Now I'm going to do Control-Shift F8 to execute it. And sure enough, there's my workflow executing. So again, just to make sure everyone understands what's happened here, regular PowerShell core does not support workflows. So because I have the Shell Launcher extension, I can open up additional windows. So remember, if we go to our settings, I've configured a number of different types of shell. So I have a regular Windows PowerShell option there. And in my keyboard settings, what I actually have here is under my Workbench Action Terminal Run Selected Text, if I do Control-Shift F8. So I'm pushing Control-Shift F8 instead of the normal, hey, I'm just going to run a piece of script. So that's what I'm actually doing here to make it run in my current window. So here we created a workflow called My Workflow, and I executed it. And it was that simple. But I didn't really get any benefit from that workflow. I couldn't have paused, resumed, or done anything else. And so where I really start to get power with checkpoints is I have this ability to save the state. I can say checkpoint workflow. This will contain the current values of variables, the current output, and exact location within the workflow. And that latest checkpoint is utilized to recover the workflow if there is some interruption in the execution. And I can add as many checkpoints as I want. But what I would really think about doing is I would place a checkpoint at key points within the script. Anytime the checkpoint has maybe done some piece of work, was about to do some piece of work, and I have state, I would checkpoint there. So if there's a problem, I can resume from it. There is also a workflow level checkpoint in addition to activity level checkpoints. So I have these different levels of ability to resume from various problems. So now, on the next slide, we have kind of a longer workflow. Let's just look at this directly in our editor. So here is my workflow. So it's called long workflow. I'm going to load some information. I'm going to sleep for 10 seconds. Then I'm going to checkpoint. Then I'm going to just write out performing a process. I'm going to get a list of processes. Then I'm going to sleep for 10 seconds. Then I'm going to checkpoint again. Then I'm going to write out cleaning up and then sleep for 10 seconds. This is only to give me the ability to try and demonstrate this by actually being able to pause it, resume it, and then kind of show you what it's doing. So I'm going to go ahead and let's define our workflow. It's going to execute Control-Shift F8. And now I'm going to execute it. So remember, I have activity checkpoints. These are when I call checkpoint workflow. And because I'm going to run it with PS persist true, I get a workflow checkpoint. So this is going to automatically add a checkpoint at the beginning and the end of the workflow, and then after each activity. It doesn't interfere with any explicit checkpoints I add, but I'm going to get this as well. So now I'm going to try and execute it. So we're going to run Control-Shift F8. Notice I'm running it as a job. This means it's just going to kind of run in the background and let me carry on running other commands. So I'm running this as a job. I'm giving it a job name of long workflow. Go Control-Shift F8. That's triggered it off, and there's the state. So I can automatically, suspend it. So now I can see, okay, I've sent that suspend job and it's suspending. So let's look at the status of that job. Yep, it's currently suspended. Let's have a look at the information using receive job. I can see that's what's currently been outputted to screen. And notice I'm doing keep, so it doesn't remove that. Okay, so it's done the first part. And now, okay, probably in its sleep stage. So now what I can do is I'm going to resume the job. So now it's running again. And we'll give it a little bit of time so we can do a get job on it. Yep, it's running. Let's see what it's doing. So now it's done the get process part. But it's still running right now. It might have slept, so I could, for example, suspend it again. I could get a list of what's been output so far. So now it says cleaning up. So it's done this last part of the sleep. And I guess now I'll let it resume again. Oh, it actually already completed. I was a little bit slow on that one. So if we actually look, so it's now finished. But you kind of get the idea of what it was doing. It enabled me to pause it, resume it, and although I was manually doing the pause and resume, if something had happened to the machine, well, those would have been used in exactly the same way. It would have carried on from where it was running. And then once I'm finished, I can go ahead and actually remove the job completely. So if I go all the way, scroll down. Now I've removed it. If I try and do a receive job now, it's gone. So that's the idea of the workflow. Something that typically is going to run for a longer duration, and I want to be able to resume if something happens to it in an unplanned or even a planned type scenario. And note, I ran it as a job. You don't have to. It can run just as part of the foreground, but by running it as a job, it then runs in the background, giving me control again. I get my prompt back. So that's really why it's nice to leverage these longer running things as a job. I don't want it taking up my terminal for the next hour. Now, some things I'm fine running sequentially. Do this, then do the next thing. But if I was writing this to run against a lot of machines, well, why do I want to run them one at a time? Especially when I'm using resources on the remote machine, well, I may as well run these things in parallel. And so there are new keywords specific to workflow and those parallel type activities, namely parallel. And then we did for each before. Well, now I can add parallel to that. So let's have a look at this. This is a terrible, terrible output. I'm just mixing a bunch of random commands together. But you're going to get the idea of what it's doing and showing, hey, they're actually running at the same time, not one after each other. So this is a workflow called parallel test. And in parallel, I'm going to get all the processes beginning with W, then S, then X, and then I'm getting the event log. And then we're going to run that. And notice it's saying parallel. So if we scroll down to my parallel test, so I'm going to run that, Control-Shift F8, so I've defined it, and then I ran it as well. I ran the parallel test. So it's outputting all this stuff, but you're kind of seeing there were things just kind of being randomly put in all over the place. It wasn't this very neat layout. So there's some services, there's an event log, there's some more processes, but then there's another event log. They're all running at the same time. So there's an W, there's an S, a WS. It's just all over the place. Because it's not running get process W, then S, then X, then event log. They're all running at the same time. So they're all throwing their output to us at the same time as well. Likewise, I can run those concurrent actions. Now I have my for each, but I'm doing dash parallel. So I have a list of VMs. And now I'm saying for each parallel VM in VM list, move them. So instead of it moving VM blank 1, then blank 2, then blank 3, then blank 4, it's going to trigger that across all 6 at the same time. I'm just going to now live migrate a whole bunch of virtual machines together. I can still pass parameters, just like a regular functional script. I have my workflow, I can accept parameters, and then I can actually go and get information about those various machines. So here you can see I've got that same workflow. I'm going to define it. Execute, Control-Shift F8 to run it in my current window. I'm going to execute by passing it these two machines. And I got my output. So there's the information about those two machines that I went and grabbed the information for. So parameter passing works exactly the same way as just a regular script or a function. I can force certain actions to run in sequence though. Sometimes I don't want to run it in parallel. I need them to run in sequence. So I can use a sequence block. For example, hey, there's that same thing, run it in parallel. But then within that running in parallel, I want you to run these commands in sequence. Get the operating system, then go and get the computer system information. And then run those. So I can just add that in, and then control that is now going to run sequentially. Here's kind of a better example of the sequence. Well, okay, so I've got this parallel sequence, just the processes W, then S. Then I can get the services X and get the security information. So if we jump over, let's go and look. So what do we do first? Well, first we have to define a workflow. And then once it's defined, I can execute it. So you can still see I've got kind of this bit of a mess going on here because some of it was running in sequence, some of it was still running in parallel. But what I should definitely not see is a mix of processes W and S. I should see all the processes W first. So we scroll up. So sure enough, there's the W's. And then after that, because it's running those commands sequentially, then I should start seeing the S's. That's showing you how I can force things to run in sequence when I need them to. Now, I cannot use regular methods like add type or load with partial names. I cannot load assemblies in a workflow. Instead, I use an inline script. So for example, here I'm saying, hey, the new password is equal to a new inline script, and then I can use the regular types of assembly that I might use in a script. So here I'm loading in the system.web, and I'm using a security membership to generate a password. So that's how I can use assemblies. This is a more advanced construct, but I can still do it. I just can't do it directly within my workflow. Within my workflow, I'm going to call an inline script when I need to hook into those assemblies. Because there are restrictions in workflows. However, inline script will often save us. I cannot use a method invocation, i.e. $string to lower. Remember, the dot means I'm using a method of an object. Well, I can't do that. But I could do it within an inline script, or I can convert it prior to doing the work. I cannot use a case-insensitive switch statement, but I could use an inline script again, or convert it to one case first and then use case-sensitive, which, remember, if I'm going to convert the case, I need an inline script there as well. There is no $global scope for variables. And to be honest, some command lines just will not function, especially if it requires interactive environment. Now, to be honest, you shouldn't really be having things with an interactive environment anyway, because this is a workflow. It's running headless. There shouldn't be a big use case, but there are some strange commandlets that still use that. And so use an inline script. For example, just some of these things changing case. If my message test wanted to convert a string to upper, well then I'm just going to use an inline script to call that command I want to run. So my message test equals an inline script. Using means I can use things at the sort of parent layer of the process. where the variables were defined. So I'm going to use the message test variable, convert it to upper, and then pass that value back. So that's going to help solve a lot of my kind of workflow pain. And here's just kind of an example of that. So we have our workflow restriction check. And I can see here, I've got a message called hello. And if I tried to just do message test dot to upper, so we'll uncomment this. And if I Control Shift F8, it fails. It does not understand that. So we're going to comment that out. And instead, doing exactly the same thing, but I'm just wrapping it in an inline script. So now I'm going to try and execute that again. And then run it. And that errored because I pushed F8. Notice it switched console. So I should have done Control Shift F8. And there we go. So that's how I can work around some of those challenges. I wanted to finish out this module just walking through two kind of very current technologies to actually run my PowerShell. Now this could be PowerShell workflows, it could be regular PowerShell, depending on which of these services I utilize. Because, yep, PowerShell workflows are great. I still need to run them from somewhere. I have regular PowerShell, I want to run it from somewhere. And so Azure Automation started off life as really a runbook engine for PowerShell workflows. And then it evolved to support regular PowerShell and even Python 2. So it lets me create these runbooks, which are PowerShell scripts, PowerShell workflows, or Python 2 creations. And then it provides the engine to run them. I can create schedules to define when it should run. I can trigger them from hooks via a RESTful API. It does give me an output so I can view execution. And don't think of it as, well, I can run PowerShell related to Azure. I can import additional modules. I can reach into my on-premises environments and other clouds. So it really does give me PowerShell to anything. I'm not limited to, hey, just within this little PowerShell box within Azure. Don't use commandlets that are based on interaction. There's no point trying to get information from the host, or I'm formatting things for an output. It's designed to run things that are doing work. Maybe it's shutting down VMs. Maybe it's creating some things. Maybe it's performing a scale action. It's not designed to say, hey, let's get some interactive stuff going on. It's not going to work. Now, there are textual and graphical modes. And I'll show this in a second. It has its own sets of assets, including credentials, which on the back end is going to use Key Vault. So whereas I showed script in one of the previous modules to write to Key Vault and get from Key Vault, I don't have to do this here. It will just have its own native credential, and I can get that using a PowerShell command. And it even will actually create a service principal that has full rights over my Azure subscription and let me hook in via that, so I don't even have to worry about any credential and updating passwords. So think about, hey, starting VMs, stopping VMs, creating VMs on a scenario, patching. It's just going to do all of this for me. So if I jump over, I've created an automation account, and it has a whole set of different capabilities now. I can do inventory and change tracking, PowerShell DSC. I can think about patching machines, and it actually uses little runbooks, and we're going to talk about something called a hybrid runbook worker that lets me reach out and send commands to something else. Well, I can utilize that to control patching for multiple machines. What we're focused on is this process automation. I have these runbooks. There's a gallery. People have created huge numbers of these runbooks for me. There are shared resources, modules. I can go and add modules to my automation account. I can click a button to automatically update the Azure modules. I can go and add a module, actually upload it. I can browse the gallery, and from the gallery import modules that I care about. And these modules apply not just to my runbooks, they apply to things like desired state configuration. So I added in the X Web Administration module so I could use that IIS management from within DSC. So these different capabilities, this is going to go and browse now. I don't really care about waiting for that to finish. I have credentials I can add. I have connections. So here I've got an Azure Run As connection. This created automatically for me. I can hold certificates. I can hold variables. And you'll see here we have these Run As accounts. These are managed by the automation account itself. I've already gone ahead and clicked the create the Azure Run As account. It can also create me a classic Run As account if I'm still dealing with the classic Azure Service Manager, although hopefully none of you are. Everyone's on Azure Resource Manager now. And all this does is it creates a application, if you will, within your Azure Active Directory. And then through that, it loads a certificate, and then it gives that application rights on my Azure subscription. What this basically means is I can do anything within the Azure subscription that I create this under. So if I actually went and looked at my Azure Active Directory, if I went and looked at my app registrations, and I looked at all of my apps, you'll actually see what it's done is it created this automation application. Then under that, it's going to go ahead and create a secret. Now, these secrets show under keys. This could be a password, or it can actually be a certificate. So that's what it's using to actually interact. And then once it's done that, what it's doing behind the scenes is on the subscription, it just gives that application rights to really do anything it wants. So if I actually go and look, there's my automation. It gave it contributor rights at the subscription level. So it did all of that for me just by clicking, hey, create that. It's given the automation account a very easy way to now interact with everything in my Azure sub. And when you do that, not only does it create the account, it creates me these little samples. And I'm actually going to use these. Now, interestingly enough, the script it created didn't actually work off of the bat. I actually had to modify it. So we can do edit. And what you'll see here is it shows me all of the assets I have available. So I have variables, connections, and I have credentials. And all the different commandlets and runbooks. So what it does here is you'll see it gets my service principal connection. And it's getting the automation connection name. And that connection name was Azure Run As connection, i.e. this. But here's what's really cool. If I just create a line here, if I select that and say add to canvas, it actually adds in the PowerShell to get this asset for me. So if I did an actual just regular credential, add to canvas, it gives me the PowerShell to grab it. And then I could go and set a variable to actually store it. So it makes it super easy to leverage these things. But what this is going to do is, hey, get that connection, add it, and then it's going to go and iterate through all the resource groups and then find me the resources in each resource group. So it's using a for each resource group in resource groups. Resource groups was found by doing a list of all of them. And that's it. It's just regular PowerShell. But I can easily hook into these assets. So I'm now not worrying about, well, where do I store a credential? How do I do this? And if I open up the test pane, I could just hit start. Now realize what's happening here. I have this PowerShell. it's not running interactively. Azure Automation has a huge amount of compute power and is now queuing up mine. And then when it has a worker ready, it brings up this isolated environment so I can't interfere with anyone else's. It's going to run it. And then this window will receive the output. It would also save it to a log. That's showing me, hey, look, it's running. And the output stream will display when the test completes. So that's going. And then I'll see the output. Now, I'm not trying to cover Azure Automation in detail. This is a PowerShell course. I'm really just trying to highlight this is available as an option to run your PowerShell. And this is the one I would actually probably recommend the most right now. I think Azure Automation is a phenomenal engine to run my PowerShell. So it finished, and then it's showing me all the resources I had. It's showing me that output. If I'm happy with my test, I would publish it. Once it's published, well, now I could actually go ahead and run it whenever I wanted. I could create a schedule to run it under. I could create a webhook so I can call it from a RESTful API. So that's a regular PowerShell runbook. They also have graphical runbooks. I'll be honest, I'm not a huge fan of these. I don't fully understand the goal of them. It's easier to view. You can see, hey, look, I'm getting a run as credential, a connection. Then I'm logging in, so I can label each box. But each box is essentially running a PowerShell command, a commandlet. And I still have to populate all of the parameters. Now, it gives me a nice little, I guess, graphical way to populate the data. It's easier for me if I don't understand programming to understand what's happening. Oh, well, look, it's getting a credential, it's logging in, it's getting the resource groups, it's getting the resources, and then it's writing outbound. Then it's got, hey, look, I can have conditions on these lines on, well, yep, I apply this condition, get run as connection, etc. But it takes forever to do anything with this. So I have to add each command at a time, fill it all in. So yes, it's nice to look at if I don't really understand PowerShell, but honestly, if you don't understand PowerShell, I still don't think you could use this graphical approach. It would take too long. You still have to know the commands that you should be using. But it is there. It's definitely an option. And then, of course, I have the ability to run Python, which is something I'm not even going to touch. So the point is, these automation accounts, I can basically host my PowerShell scripts, and I can run my PowerShell workflows. And when I create a runbook, it's going to ask me, well, what type do I want to create? A workflow or just regular PowerShell? Or I can import if I have a file, or I can browse the gallery. And the gallery, there's just a ridiculous amount of scripts already created for you. And I could just search for the type of action I'm trying to perform, and there's probably something out there already. So that's Azure Automation. And I also can hook into on-premises. Now, yes, I could technically open up firewalls to expose my Windows management point to the internet. That would be a terrible, terrible idea. I could create a single VM on premises that is exposed to Azure Automation, and through that, perform actions to other VMs. But then I'm having to kind of manage that myself. The better option is to leverage Azure Automation Hybrid Runbook Worker. These OS instances that I create run the OMS Microsoft Management Agent. The Hybrid Runbook Worker will be pulled down and installed, and then it establishes an outbound connection over HTTPS to Azure Automation, and then listens. Hey, should I be doing something? And then when there is something it should be doing, well, it will then go and run the commands against the machines on its local network. So now Azure Automation's reach has been expanded to anything that runbook worker can talk to. So I could run a whole set of actions against my on-premises machines as well. Now, recently, Azure Functions has been talked about as a mechanism to run PowerShell. Azure Functions is one of the serverless compute options in Azure. It's purely consumption-based. I pay for the compute cycles it uses. Unless I make it part of an app service plan, I have a choice there. But it supports .NET, JavaScript, and I can actually run PowerShell along with regular like C# code, for example. It has a number of trigger types. This could be a schedule, it could be a REST trigger. And I'm not sure which direction things are going to go. Today I think about, well, I'm probably going to use Azure Automation for most things, especially if it's a longer running type job. I might use a function for a very short time execution that's triggered maybe by that REST API. It has got more flexible scheduling. So if I was to jump over here, now what we'll do is search for now is function. And you'll see I've got my, just look at function apps. And what I can do from here is there's like experimental features. So PowerShell today is kind of in preview. But that's going to change. It will become more mainstream. So here you can see I've already got kind of a function created called time trigger PowerShell 1. But if I actually went to my functions and clicked add, you'll see here currently I've got experimental language support disabled. And so my languages are C#, F#, JavaScript, and Python. If I set to enabled, well, now I get PowerShell and TypeScript and some other options, Bash, Batch, etc. So if I selected PowerShell, I can use some of the examples, and it's going to show me the ones that have PowerShell. So I could trigger based on HTTP trigger. So if I get this RESTful HTTP request, I can run this PowerShell. I could trigger on a time based on a queue entry. So someone writes a message, it will trigger my PowerShell. So if I select, for example, the HTTP trigger, and I want the PowerShell example, I can just say create. And it's going to create me a basic PS1 file. And then I would modify it to actually do whatever actions I actually want. So you can see it's giving me here a variable that's going to be populated with the content that is sent to me as part of the post. I have a name. Then I can perform something. And then by default, it's just going to say, okay, I'm going to send outbound hello, whatever you actually got sent to me as part of the arguments. So hello name. So nothing particularly fantastic by default, but I would modify this to actually do something useful for me. I wanted to make a RESTful call to this. I could pass a parameter called name by default. So it's looking for the name parameter in the request body. But I could add my own ones. I could add extra things. I could do real work within this function. So if I just save this, if we were to just to run this by default, you could see you're connected to log streaming, function started, function complete. I could see the console that I'm running under, any errors and warnings. So it's kind of just a very basic view, but that's not super useful. If I could see the output over here, it's hard to do it in this very small window. Hello Azure. Because by default, it knows what it's expecting. And so it's giving me this default request body, and that's what it's sending it. So it sent it the name parameter, and it set it to Azure. So I could run it again. And it's going to be giving me that same output. Now, what's useful about this is I actually have this URL. So if I do my get function URL, I could copy this to the clipboard. So there's everything to call this function. So if I copied that, I'm going to close that for a second. If we open up our project, so what I'm going to do is try and use that. So I'm just going to say, we create a variable called the function URL, and we'll set it to that value. It's that great big long value. And so now I should be able to call invoke REST method. And the method is get. The URI is the function URL. So if I define this, F8, and then run it, I just got hello. Now, why didn't it say hello Azure? Well, remember, when I was testing it in here, as part of the test option, it had a request body. And the request body gave me this default Azure name. But that's not a default within the script itself. This was part of the testing window where I can add my own body. The script has no default. The script wants me to send it a name. Okay, so what I can do then is, that kind of worked. But what I want to do now is I'm going to copy this line, and that function URI, well, I need to change it. So I need to send it, yes, that base URL. So I want to pass it that URL, but I want to add to it my parameter. So that's ampersand name equals John. So we'll invoke that again. And that says hello John. Perfect. Now there's other ways I could do that. I could actually send it a body. Exactly the same way the test function worked, where it had this test body as part of a JSON. I could do that. I could create a hash table with my various options in it. I could then convert that to JSON and send that along with it as well. So instead of that approach, I could actually create myself a JSON body. And I'm going to create that by creating a hash table. So name equals John. So that's a hash table just with one name value. And I can use the convert to JSON. So if I run this line and then look at JSON body, what do I have? Yep, I have some nice JSON created for me there. So now I can take this exact same command again, but this time my method is I'm posting. I'm going to post a body to it, and the body is going to be my JSON body, and the URL stays the same. And in fact, just to be accurate, I should really change the name. So we'll now go with the old traditional, we'll say world. So my JSON body is going to be world. If I run it now passing it body, I get hello world. So that's using Azure Function. I have my PowerShell in there. And I think I could do anything with that. I could start a VM. I could stop a VM. Now, one of the things you have to be careful of is, well, how am I controlling security? Who can run that? And you'll notice that as part of this, it has kind of this code. So it's kind of security through obscurity. You have to know this to be able to run it. Now, obviously, in my case, I've put this out on the web. And so I'm going to quickly delete this because I don't want to leave this hanging around. But there are other ways you can lock this down. If you're really interested in using this, you can go and look up. There are other checks you could perform. But this is another great way to go ahead and actually run pieces of PowerShell you might have. So I have Azure Automation, I have Azure Functions. I think Azure Automation, phenomenal for longer running PowerShell. Maybe that's how I make that decision today. And then I would think about Functions for maybe those shorter triggered pieces of PowerShell. But I don't think there's a right or wrong. Definitely Azure Automation is right for workflows, that very long running, that centralized view. But I could still use it for the shorter running as well. But you just notice how fast Azure Functions trigger with that consumption base. It was just there. I didn't have to wait for it to get queued to execute. I just get that response straight away. So this was the last module of my kind of planned content. Over time, based on feedback, I might add additional things in Check the Playlist. I'll tweet about them. So please follow me on Twitter at NTFAQGuy. I hope you enjoyed this course. Please give me feedback, share it with your friends, and I'll look to maybe create more of these about other topics. Also, check out all my courses I have on Pluralsight. I do a lot of content there as well. And good luck in all of your PowerShell endeavors. Thank you.